Welcome to this tutorial on the Tower of Hanoi. So what is the Tower of Hanoi? The Tower of Hanoi was a puzzle invented by the French mathematician Édouard Lucas in 1883. The goal of the puzzle is to stack all the discs onto the far right pole. However, there are three rules that must be followed. Rule 1 states that only one disc can be moved at a time. Rule 2 consists that each move must consist of taking the upper disc from one of the stacks and placing it on top of another stack or on an empty rod. Rule 3 states that no larger disc may be placed on top of a smaller disc. So let's take a look at the puzzle again. In order to do the puzzle in the fewest moves possible, we need to move our yellow disc to the right pole. Following that, we need to move our green disc to the middle pole, then the yellow disc on top of the green disc, the blue disc to the right pole, the yellow disc to the left pole, the green disc on top of the blue disc, and then finally the yellow disc on top of the green disc. Now this solution requires 7 steps and is the absolute fewest steps that can be taken in order to complete the puzzle. However, the puzzle is not limited to just 3 discs. We can use as many discs as we want, and it will always follow the same pattern. Let's take a look at just a single disc. Now you'll notice that the other 2 poles here have been labeled as even and odd. These posts will change depending on the number of discs we are using for the puzzle. If we are using an odd number of discs, the middle post will be even and the right post will be odd. If the number of discs used is even, the middle pole will be odd and the right pole will be even. Even and odd will represent how many discs we are going to stack on that pole when the discs are stacked to a maximum height for that base. For instance, for one disc, since we are making a tower of 1 high, we will stack it onto the odd pole, resulting in 1 move. If we move on to 2 discs, you'll notice that the 2 poles have switched, and now we have even on the right and odd on the left. Now we'll move the yellow disc to our odd pole, since it can only stack up to a tower of 1 high, and then we'll move the green disc to the even pole, since it can stack a tower up to 2 high. Finally, we'll move the yellow disc on top of the green disc and complete our solution. Now let's take a look again at our 3 discs. You'll notice that the odd is on the right and the even pole is on the left. And if we watch this solution this time, you'll notice that every time our base moves that will be stacked upon, it will always move to a pole that is labeled for how high it can build a tower. The yellow disc and the blue disc being 1 and 3 both move to our odd pole, and the green disc being 2 move to our even pole. Let's take a look at this again, but with 4 discs. You'll notice this time the even and odd poles have switched, and that when we do this, once again, our smallest one will go to the odd, our one that can be stacked 2 high will go to even, our green one, since it can be stacked 3 high, will go to odd. Once we have stacked on top of that, our blue disc, which can be stacked 4 high, will move to the even pole, at which point it will then be stacked upon to a point at which it makes 4 discs. You notice that the problems always do the same thing that the smaller versions did, but on the opposite pole. This is an example of recursion, which we have briefly talked about recently, where we can take a smaller version of the problem and solve it, and then use that solution in the next largest problem. This means that the solution we just used for the 4 discs could be used for the 5 discs, except we would stack up to 4 discs on our middle pole, and the 5 disc would be on our right pole. This can be solved for anything up to 64, 100, any size amount of discs. It also means that we can calculate how many moves each will be required based on the previous move set.